squared is what? 9. 9 minus 4, that's positive, right? We know they're going to be infinities. Right? Because we can't divide by it, and so for sure we're going to get infinity there. You know, is it going to negative infinity or positive infinity? That's going to help us with the graph. So if I'm to the left of negative 2, even negative 2.5, when I square that, that's still going to be bigger than 4. Negative 2.1, when I square that, that's still going to be bigger than 4. Do you see from the left, for sure it's going to stay positive? That means that this is going off to positive infinity. If you're not sure, you can always use your graphing calculator. That always works for these types of problems. Let's apply the logic the other way. What happens if x is equal to 0? Is this going to be negative or positive? Negative. It's going to be negative, right? Let's say that x is equal to negative 1. What's negative 1 squared? 1. 1 minus 4 is still negative, right? So let's do negative 1.5 or something. Do you see when I square that, that's still going to be less than 4? So we're definitely going up to negative infinity here. We okay with that logic?
Yeah.
Yeah.
Could we just like look at the graph and just...
No, the whole point is we don't know what the graph looks like. Let's do the other side of it. Let's approach 2 from the left side. Again, 0 here is going to give me a negative 4. 1 is going to give me a negative 3. 1.5 is still going to be something less than 4. 1.9, still something less than 4. So this side is also going up to negative infinity. Are you with me? Next up, if I approach from numbers that are bigger than 2, you can see this will always be larger than that. For the same logic we were just doing. If it's 5, then for sure. 4, 3, 2.5, it's still going to be bigger than 4. This is going up to infinity. Yes?
When we see something like that, does it prove symmetry at all? Or could it be kind of different and wild?
It could be different and wild. It depends. There is symmetry in this particular problem, though. Questions? So let's talk about what the graph looks like so far. We know that we have asymptotes at plus minus 2, right? So let's go to our limits and see how they're going to help us. So as I approach negative 2 from this side, what's happening to the limit? So this is actually doing that. How about as I approach negative 2, going this way? It's going down to negative infinity. Same on this side, right? How about here? We're going up to infinity. So we can kind of see what our graph is starting to turn out to look like. Oh, we also have some points. Let's put our points down. So 1.37, yeah. Negative 1.37, yeah. And it's crossing the y-axis where? 3/4 is about there. You okay so far? So we have some information that's useful so far. Let's move on to horizontal asymptotes. So we're looking at the function. What happens when x gets really, really big? So let's see what happens. Notice I get infinity over infinity. So we could apply L'Hopital's. But I'm going to back away from that right now. That top derivative looks horrendous. So let's do this. Do you see that the degree in the numerator is the same as the degree in the denominator? You see that's the same? Because these become irrelevant after when x is 50 trillion, right? So we actually can say that they're the same, same degree, therefore the lead coefficient is what's going to dominate. What's the lead coefficient? 1. It's going to be 1. So this limit becomes 1 plus the 1, right? Which is 2. I know. How about the other direction? Is anything going to change? Remember we had that whole thing where we had to do that extra negative and break it into the thing and all that piece? Will that apply here? That's okay, you're totally guessing. So the answer is no, that doesn't apply here. I'm not going to try to use that here. What I'm going to do is I'm going to notice that whether x values are positive or negative, they're still going to the same place because it's to the 4th power and it's to the 2nd power. Right? So I'm not going to get a spontaneous negative coming out of that. So the answer is, this is just 2 again. So y equals 2 is the horizontal asymptote. Now, I should be asking the question, do they cross the horizontal asymptote? That does happen sometimes. How do we figure that out, you think? Look at where? What do you think? What do I do? Set it equal to 2. That's exactly right. So I'm going to go and move that over. Kind of the same. X to the 4ths are gone, right? So let's see what we get. cross the horizontal asymptote? Yeah, I'm a little suspicious because these are our x-intercepts. Anytime you square both sides, you get erroneous answers sometimes. Okay, so we have to make sense of it. Is it going to cross here and here? Can a function have two y values? No. Of the same thing? Yes.
Is that supposed to be a negative 15 array?
Yes, divided by negative 8.
No, I got it.
Yeah, so you subtract the 16, you get negative 15, and then you divide by negative 8.
Right.
Yeah. So, this isn't going to work. So the answer is no, it doesn't cross the horizontal asymptote. You do need to explore that though. So, we can add more to our graph. If it never crosses, what happens when x gets really, goes up to negative infinity? What's happening? We already did that limit. What's it approaching? It's approaching 2, right? And it doesn't cross, so it's going to do something like this. Bless you. Next up are the critical values. Yeah.
Not the day before, but the class before. Critical thinking stuff.
Oh, yeah, we did.
I did the derivative for you.